All right. Lesson 7 is going to go off of lesson 6 and talk a little bit more about incenter. So let's see. We have our warm up says use a compass to draw the largest circle you can find that fits inside each triangle. So you might not have a compass, but if you're looking at this triangle here, it looks like an equilateral triangle. So it would kind of make sense to just kind of find what would be sort of that midpoint in the triangle. So I'm just going to kind of like guess and say it's right there, and then I'm going to try and see if I can get a circle as big as I can that's still inside. That looks pretty good, but it looks like I can do a little bit bigger, maybe. Try a little bit bigger. So it looks like that's pretty much it. So all I did was I kind of figured out where the middle was, and then I just kind of said, okay, the biggest I can get is probably to there. So then I kind of set my compass that way and kind of just went around the circle. This one's going to be a little bit more complicated, but the point of this warm-up is just kind of experiment and see. I'm thinking this chunk here is going to be where we want that biggest possible circle to be, so somewhere in there. And then maybe my circle will be maybe about that big. I'll try that. Pretty close to being as big as it could be, looks like. So the idea with this is we're just going to be figuring out where the center of that circle needs to be in order to make the biggest circle we can inside of the triangle. So in lesson 6, you talked about how to construct the incenter of a triangle. So lesson 7.2 here says we want to mark 3 points and connect them with a straight edge to make a large triangle. So I'll go ahead and do that. And it says the triangle should not be equilateral, and we'll explain why not in the next thing we do. But I'm going to say that's my triangle, and I'll use my straight edge to connect those so I have a nice straight triangle. Alright, so that's my triangle, and then it wants me to construct the incenter of the triangle. I'm going to go ahead and grab a different color. Okay, so remember, to construct the incenter, we want the angle bisectors. So I'm going to go ahead and I'll find the angle bisector of this guy first. So what I'm going to do is I'm going to line it up here, and I'll zoom in a little here so you can kind of see what I'm doing. So I took that vertex there, lined it up there, and then I'm looking at where that line goes to. So it looks like it goes to right about 90, maybe like 91, 92. So then I want to figure out half of that is going to be like 45. So I'm going to mark where 45 is. Just as a reminder, it was a little bit easier with the 90 because they're both 90, but if I'm lined up on the right here, like I have my line making my angle to the right of the vertex here, then I'm going to look at the numbers on the inside here that start at 10 down here, because an angle is getting bigger like this. If you think about like my pen being the other part of the angle, it's getting bigger this way, right? So I'm going to be looking at the inside numbers here. So here's my angle bisector. I'm going to go ahead and just do a dotted line for that. And then I'll do another one. Okay, so it looks like it wasn't perfect, but it looks like they intersect right around here. So that's the intersection of my 3 angle bisectors. So that's going to be my incenter. I'm going to write that here. That's my incenter. Okay, now it says construct the segments that show the distance from the center to the sides of the triangle. So remember, we're going to make perpendicular lines to the sides from that incenter. So that's going to show the distance to each side from that incenter. So, and for this, I'm just going to kind of eyeball it, but just know that it should be kind of a right angle. So for here, there's my incenter. I want to make a right angle with the side there. So it's going to be something like that. And then here, I want to make a right angle with the side. So something like that. And then here. Okay, so those lines are showing the distance to each side from the incenter, and remember, those should all be the same distance. Those should all be the same length. All right, and then it says construct a circle centered at the incenter using one of the segments you just constructed as a radius. So it wants me to take this as my center, and it wants me to take one of those yellow line segments as my radius. So I'm gonna go ahead and just do that. I'll lock my compass here so it doesn't move. And I'll kind of zoom out here so you can kind of see. All right, so it looks like that wasn't perfect, but you kind of get the idea. That should be the biggest circle you can draw inside the circle. So it should be touching the sides. It looks like maybe I was a little bit off with my positioning of my compass or something like that. But it looks like that's going to be my inscribed circle. That's what we call that, the inscribed circle. The last question says, would it matter which of these 3 segments you use? So looking at those yellow ones, would it matter which one of those I used as my radius of my circle? And the answer is no, because they're all the same length. They're all the same length from here to the side. So any of those should work, because they all should be the same length. And that's going to be how you find your incenter. So I'm not worried here about you being perfect with your drawing. I'm more worried that you understand the concept and you're at least following the idea of the process, even if it doesn't end up being perfect. Yeah. Okay. So that's what we call the inscribed circle. So the incenter is the center of the inscribed circle. So I'll go ahead and write that. Okay. And now we have one more thing here. And it's a proof. And I'm not even gonna go through and write the whole proof down. I'm just gonna kind of talk about it. So it says the image shows an equilateral triangle ABC. The angle bisectors are drawn. The incenter is plotted and labeled D. So it says D is the incenter right here. We know that's the incenter. And then it says prove that the incenter is also the circumcenter. So the idea here is that the incenter of an equilateral triangle is also going to be the circumcenter. So that only works for equilateral triangles. So for an equilateral triangle, the incenter and the circumcenter are at the same point. So we want to prove that this is the circumcenter, knowing that this is the incenter, and knowing that this is a equilateral triangle. So I'm just going to kind of go through and explain the idea with this proof here. So what we know, first of all, is that this is the incenter, which we know is equidistant from the three sides, right? If we want to prove that it's the circumcenter, well, we know the circumcenter is equidistant from the three vertices. So we need to prove that this point is equidistant from the three vertices, because that would mean that it's the circumcenter. So how do we prove that? Well, let's think about this. So I have these lines. I'm trying to prove that those are all the same length. So if we think about, so I know that this length here, I'm kind of just freehanding it here, but all of these, if these are all right angles, all of those should be the same length, because we know that's the incenter. D is the incenter. So these should all be the same length. We know that much. So if we know those are the same length, now you can kind of see how when we drew those green lines there, we made 6 little right triangles. So the idea with these 6 little right triangles is that if we can prove that these 6 little right triangles are all congruent, then that means that these 3 blue line segments are congruent. So let's think about how we could prove that these 6 little triangles are congruent to each other. Well, we know that these little legs on all the triangles are the same length. We also know they're all right triangles, right? What else do we know? Well, we know that you might be tempted to say we know that these two line segments are congruent, and like these two and these two, but we don't know that, because we don't know that this is the angle or the perpendicular bisector. So we can't do that. What we do know is if this is an equilateral triangle, this whole angle here is 60 degrees, 60 degrees, 60 degrees, which means that this little angle here is 30 degrees, 30 degrees, because we know these are the angle bisectors. So 30 degrees, blah, blah, blah. All of them are 30. And then that tells us that these other angles are 60 up here. Here, here, here. All of those are 60. So now we know that these are all 30, 60, 90 triangles. We know that this side is the same length in all of them. So basically we can say we have a angle side, or side angle, or whatever you want to call it, and we can prove that these are all congruent triangles. So basically we can prove that all 6 of these little right triangles are congruent, which means that these little blue line segments here have to be congruent, which means that D is equidistant from the 3 vertices, which means that D is the circumcenter. Okay, I hope that made sense. Okay, so that's it for incenter. So be careful not to get incenter and circumcenter confused. The incenter is constructed from the angle bisectors, and then that point is equidistant from the sides of the triangle. For the circumcenter, you use the perpendicular bisectors of the sides, and then that point is equidistant from the vertices of the triangle. So don't get the two confused. Be careful with that. Make sure you have the two definitions written down somewhere. yeah, so that's going to be it for that. And this is all we have to do for drawing now. So we're not going to be drawing anymore or doing any more compass stuff anymore. So that'll be it for kind of construction type things, and the rest of the unit will be a little bit more algebra type things rather than this kind of thing.